So first of all, my name is Yomiyu and I'm a sophomore in the EE department. Um, and I'm thankful for you have given me the chance to make a presentation, even though I'm an undergraduate student. So without further ado, I will go to the presentation. So in this presentation, I will try to deliver an introduction to Grover's algorithm and try to explain how the algorithm works in an undergraduate student-friendly manner. And I will also try to assess the potential problems that this algorithm would solve. And I also try to give an example of an improvement made to the algorithm. This snapshot was taken from a YouTube lecture provided by Dr. Love Grover, the person responsible for the algorithm, and he discusses that the 21st century would be the age of quantum, as quantum computers, through research, hopefully would be able to solve some problems which classical computers could not. So and he also discusses how quantum searching is found in photosynthesis and DNA sequencing, and how quantum computers could potentially be used for DNA sequencing. As an introduction, in quantum computing, there are only a few algorithms which have been found to show that quantum computers would have an absolute advantage over classical computers. So Shor's algorithm is the first one, and Grover's algorithm is the second one. Grover's algorithm deals with the problem of conducting a search through some unstructured search space. In computing, there are different, in data, data could be structured or unstructured based on certain criterion, and Grover's algorithm is suitable for dealing with search inquiries through unstructured search spaces. And Love Grover showed that the algorithm could be sped up on a quantum computer significantly. So basically what the algorithm does is, given a search space of size n and no prior knowledge about the structure of the information in it, if we try to find an element of that search space satisfying a certain property, we could apply this algorithm. And classically, in a classical system, an inquiry would take n over 2 trials for n being the length of the search space. For instance, we could be searching for a certain word in a dictionary with 1 million words, and there could be three letters have been given. So a classical system would need to examine 500,000 words till it finds the right word. The correct word for this puzzle is piranha, but a quantum mechanical superposition through Grover's algorithm would take advantage of the implication provided by the algorithm, and it would reduce the time taken by a square root factor or by a quadratic factor. So that means a quantum search algorithm would find the right answer within 1,000 steps. This is a reference to the paper in which the Love Grover proved that a quantum mechanical algorithm would have a quadratic advantage over a classical algorithm when it comes to unstructured database search. So Grover's algorithm is appreciated because it's one of the few proven algorithms whereby quantum computers could achieve significant advantage over their classical counterparts. The problem with coming up with quantum suitable algorithms is one is human intuition is rooted in the classical world, since most of our all of our interactions are classical, and when we look for algorithms which we could apply in quantum computers to get some advantage, those algorithms need to be better than any existing classical algorithm. So the Grover's algorithm is a really important algorithm because it's one of the rare cases in which quantum computers have been found proven to be advantageous. So how does Grover's algorithm work, you might wonder. Any search, any binary search, I found this formula from The Art of Computer Programming. So any binary search would if someone guesses the amount of the probability for searching would be given by such formula, but using the Grover search circuit, which contains two Hadamard transforms, would enable us to process this in a quadratic speed. So I took snapshots of the explanation for Grover's algorithm found on the Qiskit website because I found them to be illustrative and simple. So basically in Grover's algorithm, there is a concept called amplitude amplification, and this procedure stretches out the amplitude of the marked item, which shrinks the other item's amplitude by using two transforms. And the first step is the amplitude amplification procedure starts out in the uniform superposition, which is easily constructed from the Hadamard transform of a zero vector space. And then let's assume this to be a search space, and this is the value we're looking for. So we apply the oracle reflection UF to the state in order to, by taking advantage of the superposition property, and we now apply an additional reflection, which is an additional transform, and this transformation maps the state and completes it. So after T steps, we will be in a state whereby the transforms would lead us to after such rotations, we could find that the amplitude would be amplified. But since we're dealing with amplitudes and not probabilities, the vector space's dimension enters a square root. So the amplitude is the one being amplified in this procedure. So now I'd like to discuss the use cases of Grover's algorithm. So Grover's algorithm could be applied to spatial searching problems. For a vertex graph, when we're searching for, as I mentioned before, queries using classical algorithms, we would have an big O(n) efficiency, but then the effectiveness of the algorithm would be amplified by a quadratic factor. So as we know, the world is getting more and more technologically advanced, and there are many Internet of data coming from Internet of Things devices. So using Grover's algorithm would help us sort unstructured data coming from different sources, including images, audio, video, word processing files, email, spreadsheets being recorded from different tech devices. And it can also, I read that even though I'm not, I'm just a beginner in the field, I read that any problem which could be solved by random brute force search can take advantage of the quadratic speedup that's provided by the algorithm. and I also read that it could be applied to quantum searching and cryptography, because in addition to Shor's algorithm, the Grover's algorithm is said to provide search with block cipher hash functions and password hashing in cryptography. And I read to end my presentation, I'd like to mention an interesting paper that I read about improving this algorithm. After it was proven to be the best, a better alternative to the classical database search algorithms, it was thought that it wouldn't be possible to improve the algorithm, and there is actually a paper proving this. But in some instance, there's a mathematical method that they use to improve the Grover's algorithm in a standard database search problem, and this new algorithm would take about 0.34 times the square root of the number of data bits iterations than the regular quantum search algorithm. If you're interested, you can read more about this paper using this information. Thank you for your attention.
Okay, thank you for your presentation. Like you present the follow-up papers for the global algorithm. Okay, so does anyone have questions?